Hello and welcome back to the channel. Let me show you what we'll work on today. So as you can see, this is the River Ride game, the classic game from old, I believe, Commodore computer that will work on today in Godot. And you have your fuel being refilled, you have your enemies being destroyed, bridges, different type of enemies, and you can crash. And from here on, you can add more to your level. So we'll work on stuff like player controls, camera, shooting, enemies, building the map, all the code stuff to try and make it work in Godot. So let's jump straight into it. Let's start by setting up our project. As you can see, I'm using the latest version 0.4 beta free, and I encourage you to go to Godot website and download the latest version so that we can work in the very same environment. So let me start by going to create new project and finding the proper place for it. I'm gonna create new folder and I'm gonna call this River Ride tutorial and select current. Let's see, I don't want to have the create folder checked here in the create new project dialog because that's gonna create additional level folder here in my folder. For the project, I already have this set up, so I'm switching this off. The renderer, the game is so simple that it doesn't really matter right now. I'm gonna go with a compatibility, but you can go with forward or mobile. It's gonna be pretty much the same since this is very simple pixel art. Let's create the project. And let's switch to 2D. First thing I'm going to do is I will be bringing in the assets. There's a link in the description so you can download all the assets. Let's create a folder and we'll talk shortly about these. So let me just bring that in. And I can copy whole folder. Let's review this real quick. These are the free, royalty-free sounds I downloaded from the internet, right? This is like bomb explosion, shoot, and sound of the thrusters, right? Then we have some pixel FX effects for explosions. We have a fuel indicator, which is basically just a red bar. The fuel meter, which is a part of the UI, and the sprite sheets, which are definitely not professional because this is my attempt at pixel art, and to be honest, I'm not really good at art, but who cares, we can still make a game out of it. So that's it. When it comes to the settings that we need, there's a few, so let's review those real quick. Let me check my notes here. Let's set the default color. So if you go to project settings and search for clear, in the rendering environment you will find default clear color, and we'll go for a nice bluish color. Really up to you, but something that fits the game and looks like a sky. Maybe bring the saturation a little bit lower. I guess this is fine. If you'd like to use the very same value, this is 5D8 4C2. But if you have different type of blue, that's also fine. Then continuing on that, when we go to rendering textures, since we will be using pixel art and we'd like our images to stay sharp, we're gonna switch the default texture filter to nearest from linear. And then one more thing that we need, I believe, is the behavior of the window. So let's go to display, window, and let's see what do we need checked here. We can keep the aspect, scale is okay. I believe all of these defaults are okay. The last thing that we're gonna do in this part is add the input map to control the inputs of our player. So let's start by adding right action, left action, accelerate, and decelerate, and then we'll add shoot. So that's gonna be obviously D, A, W, S, and space. And let me just bring the mouse highlight so we can see where my cursor is. And I believe that's mainly it when it comes to our setup. So let's save all of that, and in the next section we'll start working on our map. Okay, let's start working on our map. So what I will do typically is start by creating main node. So let's select the empty node, just node, and I will rename this to main, which we will use later. And you can already save it, so press Ctrl S and create new folder. And let's call this scenes. And let's save it. So this is like our highest point in our tree of nodes. Let's start by creating new tile layer, and I will call this main tile layer, but you can also call this something like map tile layer. This where our tile is going to be. And what we need obviously is a tile set, because tile map can't work without it. So let's go to new tile set, and we need to bring the tile map sheet or tile sheet for our tile set. So you can see that with a tile layer selected, we have two new buttons at the bottom, tile set and tile map. You can just grab the sprite sheet and drop it down. There's going to be a pop-up window stating that the Atlas texture was modified. Would you like to automatically create tiles in the Atlas? And let's say yes. And as you can see, you can zoom in with a mouse button. It works out of the box because I tried to basically match everything. And let's see actually what do we have here. So we have our player with right and left turning. The projectile we're gonna shoot, so this is like, I don't know, this is my concept of a rocket. The jet enemy, the helicopter enemy, and the ship enemy, and then there's a set of tiles for the map. The decoration, which is going to be a simple tree and a house. The road, the bridge. Here's also the indicator for the power level and the power meter. We're not using fuel. And then we have a power bar instead of a fuel bar like we have in the original game. And that's basically it. As I said, they were created by me, so the art level is, let's say, mid. Yeah, but this is our tile set, and basically we can already start painting on it, right? So if I were to select that, right, I can already paint something here. So this is all good. Let's focus on how our game should look like. So let's start by grabbing this one, and I can remove those with right mouse click. See, 1, 2, 3, 4, 5. I would like to start by getting, I don't know, maybe like 5 or 6 tiles on each side. So let's start painting here, and let's switch to rectangle mode so we can cover bigger area, because this is just to create the outlines of our map, and we will add more details as needed. Okay, the same here. So we have like 1, 2, 3, 4, 5, 6, 7, I believe. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 6, 7. We don't need that. Okay, and let's just add another big wall of green pasture here. Okay, and what we will do probably is we will get rid of that a little bit and of that. The map does not matter as much. It just has to be created, so I encourage you to be creative here, right? Even though there are some guidelines when it comes to how the original levels were structured. Basically, the original levels are mostly generated on the fly based on how good the player is. Okay, and now we can add a little bit here, right? By maybe doing something like this. Oops, not that. Okay, so we can have a nice slope here. Okay, a little bit of that. Then we can basically fill that part. Again, I encourage you to go with your guts on that one. You can also speed up this video. Okay, and with that I can also select that slope and maybe I can turn it into a pattern. So I can just select this, bring it down, and let's try and use it. And we can turn it around. So I'm not going to bore you with the process of the map being created. I'm just going to speed up that part of the video. Okay, so this is going to be our map. It's kind of junky, but it will work. What I will do is I will post the link to the GitHub commit where you can download the project at this very state with all of that tedious work being done for you. So yeah, it's gonna be in the description, and we can maybe update it a little bit. So this should be a little bit clear. Again, not perfect, a little bit junky, but for the sake of the tutorial, it will work just perfectly. So let's move to the next section where we will do something more interesting and start working on our player. Okay, with that done, we can go back and start working on our player. So we'll start by creating a new scene. So let's go to scene, new scene. And our player will be based on character body 2D. So this is the first thing that we need. The other thing that we need, obviously, is the visual representation, which is going to be done by animated sprite. So let's click and add child node. Let's search for animated sprite 2D. And naturally, we will need a collision shape. Let's start by bringing the animated sprite to the here, and let's go to animation section and let's create new sprite frames. Clicking on that, it's gonna open sprite frames at the bottom here, and we need to create few animations. Let's start with the default. We will work off of our sprite sheet, so I can find the sprite sheet icon here. Add frames from sprite sheet, Ctrl Shift O. Let's navigate to our assets and sprite sheet, and we need to adjust the sprite sheet grid here. So let's change this to 16 by 16. That should be correct. You can hold Ctrl and zoom in and out with your mouse button. And the default animation is that one. So let's add one frame. Okay, very, very simple. And we can already save this. Let's start by renaming the scene to a player. And we can save this on a player TSCN. So to finish it up, let's go back to animated sprite and add two more animations. So here at the start with Ctrl N, you can add new animation. Oops, sorry, it seems that I did not have a focus in here. So Ctrl N, I'm gonna name this left, and I'm going to add another one and name this right. Since the animations are all one frame, this could also be achieved with just simple sprite 2D and replacing the sprites by code. But I believe this is a little bit more descriptive, but again, you can go with sprite 2D and it's gonna be the same. Perfect. So with that, we can add a left animation. So let's go again into our sprite sheet. And as you can see, the grid settings were remembered. So turning left, that's gonna be this one. And then turning right is going to be the opposite one. So we're turning right here, okay? And the frame rate doesn't really matter. What really matters is that the first one should autoplay on load, and they all should loop, right? Because we would love to have them on continuous play. Okay, with that we can easily set up the collision shape, which is going to be a simple rectangle. I can click on it and I know the dimensions because they have to match the tile size. So it's going to be 16 by 16, and that's going to match perfectly to our visual representation of the player. You could argue that going with something like a circle or capsule would be better, or even adding more precise collision shape. Again, I leave that to your discretion. Okay, so let's bring that into our main, so we can instantiate child scene. That's gonna be a player, and you can see already that it's here. And to play our game, we actually have to click play and say that this is the current scene, and of course main should be our current scene. So game is starting and we see nothing, right? Or at least we see only a part of the game. This is due to the fact that our camera is not set up properly. So let's actually add a simple camera, because what is being rendered right now, I don't know whether you can see it, but there's a thin dark blue line, which is like a default viewport for rendering the camera, right? And I would like to start everything from 0 point, like in the middle. What I could do is move everything to match the default viewport, but I would rather set the camera because we'll need it anyways. And since the camera is set in 0, now running it, you can see that this is aligned in the middle. Of course, it doesn't do anything yet. So let's maybe start by where there's a plenty things to do, but let's start by adding a simple movement to our player, just so that we can finally start coding, because that's the most interesting stuff. So going into our player scene, I can go click on the most top player character body to D node and click on attach a new script or existing script to select node. So let's do this. And what I will do actually is I will save it in a proper place, and I don't want it to leave the same folder as scenes. So let's create new folder, call this scripts, and player GD is fine. We'll obviously use the GD script, but the same can be of course achieved in C#. Okay, let's start by adding a class name. It's gonna be very helpful when it comes to identifying what is what. Sorry, and using autocomplete. Okay, so we have that script attached, and what I would like to do now is define some variables, right? You can do it in many different ways. Let me show you a few things here. So first thing is, obviously we'd like to export some variables, and you can do this with export decorator. Well, I don't know whether this is decorator. I'm just going to say that it is. We bump the font size a little bit, and I'm going to say acceleration, stating that this is a float, and setting it to 500. Let's also add deceleration 400, and we'll also define max speed and minimal speed. Let's say 50. Okay, and if we check the inspector panel for our player, we can see those values being exported and available even in our main scene, so that we can play around with these, right? But since all of those are closely correlated, hard word, we can group them together in an export group. And to do this, we'll add another decorator wrapping those variables. I'm going to use export group movement. And to finish the group, right, you can see it already here, grouped together. We could also do export category, which is going to create the separate category. So as you can see, you can use a little bit of hierarchy here. So when it comes to grouping of the exported variables here, you can say that category can have multiple groups. This is group 1, group 2, group 3. And each can have set of variables. It's always helpful, especially with bigger projects, to group those together so that your inspector can be analyzed and you can find your stuff quickly. But we'll go with group here. And to end the group, we simply export empty string. So export group empty string. This already makes the script more descriptive, but you can also use a region, I believe, mark. So you can go with region, player movement variables, and then you can simply end region. And this has additional benefit of being a collapsible region, which is pretty cool in my opinion. Okay, let's finally make this work a little bit. So since we are using character body 2D, to move our player, we'll use physics process function. And first thing we're going to do is the horizontal movement. Okay, so here we will handle our input of left and right. So if input is action pressed right, and then we'll do else if input is action pressed left. This is very simple. We'll just add to the velocity, which is like the inner variable of the character body 2D, to which we have access because we extend character body 2D, and if we click it, it will get us to, it will go with us to documentation, and we can find the velocity and read that this is the current velocity vector in pixels per second, and modify during calls to move and slide. So basically this is the variable that is going to be responsible for moving our player node. And I can say that the velocity x value is minimal of velocity.x plus acceleration times delta or max speed. So whichever is lower, right? Because we need to limit the speed of our aircraft to the max speed, right? And the same is going to be for the left. So velocity.x is equal to max of velocity x minus acceleration times delta minus max speed velocity, right? So we are moving left to right, but limiting ourselves to the max speed. So let's check whether that works at all. And it seems it doesn't. And there's a reason for that. All of the changes to velocity must be ended with move and slide command, which like applies the velocity. And now you can see that we're moving, although in the wrong direction, I believe. Okay, so let's check project settings. Right is D, left is A. Oh, and I know why this is happening. There's a typo. I put minus 500 here. It should, of course, be plus value. That's why we were going the opposite way. Now it works. There's one problem though. I would like to add an air resistance. So basically what that means is when we have a player, right, and we start moving in one direction, I don't want him to move there in infinity, right, like forever. I want him to slowly be stopped by some kind of air resistance or opposite force that will slowly, if you do not keep pressing the button, slowly bring his velocity like towards zero. Okay, so what we need to add is something representing the air resistance. So maybe here, this is related to movement. I can just add export var air resistance, and I'll set it to 100. So if you are not pressing left or right, I need you to slowly start going down. So you can use move towards function, and this is going to take the starting value and bring it towards the end value with an increment of delta times air resistance. So let's see how this works. So as you can see, if I do not keep on pressing left and right, we will be slowly stopped by air resistance. And the very same can be achieved for our region vertical movement. And let's also end region here. And I'm not sure I will be using those everywhere, but you get the gist of it. It is very descriptive and it helps to keep stuff organized. Okay, so the vertical movement is gonna be similar. So let's start by checking if input is action pressed accelerate, and then check for input is action press decelerate, and we'll also have else clause here. So velocity .x will also cap it. And we are using minus here because, as you can see, up direction is defined as a negative y. So just to remind you real quick that the coordinate system of our screen is a little bit different than the standard cartographic coordinate system. This is positive x and this is positive y. So if our player is moving up the screen, acceleration will have the minus y sign, right? Pretty obvious. And then for velocity dot y, sorry, that should be also velocity dot y. What we will have is a mean of velocity dot y plus, I believe this should be deceleration, yes, times delta at, and to cap it with minus speed. Okay, and if we're not pressing anything, again, I want the air resistance to kick in, but only if we are not moving forward, right? Because I want, when the player is moving up, I want the air to decelerate him and stop him, bringing his velocity to 0, but not to push him back, right? So, like, I don't know, he shouldn't be pushed back by the wind, at least in my opinion, but you can of course do what you will. Velocity, if velocity, so this should be else if velocity dot y is less than 0. Again, if it's less than 0, it means we're moving up. So don't get confused with that being less than 0. I know that it should be natural for you to say, hey, maybe it should be bigger than 0. No, we're moving up the screen. The velocity will be negative. Velocity dot y is equal to minimum of velocity y plus air resistance times delta cap at mean speed. And why not cap at 0? That's the question. Well, because in original game, if you play it, let me show you that. If you start moving by pressing W key, if you start moving, you cannot stop in place, right? Your velocity cannot really go to 0, right? You're just being slowed down to minimal speed, right? Because it would be unfair for you to stop and just, dodge things left and right. So your velocity isn't going really to 0, right? It's going towards the mean speed value. Okay, so with that, let's see how all of that works. So I can move, and yeah, I can slow down, right? But I cannot stop. So this is great. What we can also add, very simply, is the change of the sprites. So we need the reference to animated sprite 2D node. So let's just do another region here at the top, and let's say region nodes or child nodes. That makes sense. And region. Here I can just click and drag hold control and let go, and we get automatic reference for the child node. So this is going to be rather simple. We just need to play the correct animations from our animation. Where is it? So we have default left, right, and since they are looping, we will only trigger the change if they're not already playing. So we don't call it like all the time, and it gets wasteful. So let's check if animated sprite 2D animation is not equal to right. If it's not, and we're playing default or right, let's play it. Okay, the same we should do for left. So yeah, if animated sprite 2D animation is not equal to left, we can just do play left. Else we can also check if we're not playing this already. We can just say play default. Okay, so let's see. I believe they should be, let me see. Yeah, they should be the other way around, right? So let's go to animated sprite, and that should be right, and that should be left. Let's check this again. No, that's not correct still. Maybe I need to rename this like that's like left, and then this one is right. Sorry for the confusion. Oh, of course, and I changed the name here. It should be, of course, animated sprite 2D. Yeah, now it feels correct. Okay, so this is it. This is the basic setup of the player. Next step will be to set up the camera, and we will be using PhantomCamera for that, which is a great plugin. And then we'll work on our collisions. So I'll see you in the next one. Or I mean, next section, of course. In this section, let's set up the PhantomCamera, which is going to replace the default camera we're using to follow our player. So if you would like to know more about PhantomCamera and what it is and how to work with it, I encourage you to go to Phantom Camera Dev, I know, hyphen, I believe this is called hyphen. Read through the docs, follow the examples. There's a lots of great examples and many tutorials about it so that you can figure it out for your own. We will do the most basic setup for PhantomCamera just to simply follow our player. So since this is additional asset and plugin, we can go to asset lib, and here we'll search for Phantom to find the PhantomCamera, and you need to download this and install. Okay, it's gonna be in add-ons. One thing that you can check out definitely is the whole example stuff. really great, really helpful. But what we need to do for our project is go to project settings, find plugins, and here, before we can work with it, we have to have it enabled. Okay, so now it's going to be enabled, and now let's set it up properly. We need 2 nodes added to make it work. First is going to be PhantomCamera host, which has to be a child of camera 2D. Then the other one is just the PhantomCamera 2D. Okay, and here we will have few properties that we can work with. So let's see. We have to have follow mode, and we will switch it to simple. As you can see, there are many. And then we have to have a follow target, to which we can drag and drop a player, right? And with this setup, I can also increase the zoom, so this is being set closer to our player. And let's see, we have twin on load, and we would like to check follow axis lock X, because we don't need camera to move left and right. Okay, and let's try and run it now. And as you can see, we have our camera following our player, which is really great. One thing though, I would need to change to our map, because as you can see now it's too big, is to make it a little bit closer to our camera, and we can see its bounce, right? I would like to match it, because originally the game also you know, it doesn't move left and right, and the whole map fits into a camera screen. We can adjust that by going to our main tile layer, and by selecting our I don't know, grass. Let's call it a grass. And let's change this slightly to make sure that we're staying within the bounds of our camera. And also let's do this for this one. It will be a little bit too much. And yeah, this feels very rigid, but I will just simply cut this part out and cut this part out, so we have a little bit more space to play with. I can select all of this and move it to the center. Okay, and let's now try and run it. And as you can see, we did not have to code anything. We did not have to add any scripts. It just works out of the box. And we can see this green pastures left and right, and we could make those symmetrical. I'm not gonna bother with it, but go ahead and do this. So we have our camera set up, which is great. We'll continue in the next section, where we'll add physics to our tile layer. Okay, let's discuss the collisions for our tile layer, because obviously what we'd like to happen is, for whenever our wonderful aircraft hits the tile, we need to register that collision, and we need to explode our aircraft and start the game all over again. So that should be rather simple. First thing that we need to do is go to our main tile layer and have it selected, and go to tile set, and we need to paint a physics layer on top of it. So if you click on if you click on the tile set, go to paint and try to select physics to add the collision information to our layer, you will see that there's nothing there. This is because we do not have any physics layer defined. Thankfully, in our inspector, when clicking on the tile set and having it extended, I can find the physics layer and I can add element to it. So this actually requires us to discuss layers, collision layers, right? So here we have a collision layer and we can define how they are interacting with each other. Basically, if you take a look at these two rows of informations, you can say that selected node, which is main tile layer, is existing on collision layer and collides with layers on collision masks. Obviously, they are the same for now, but we can change the collision layer to being 2 instead of 1 and to be colliding with everything in the collision layer 1. Okay, and as you can see, given node can exist on the main layers, which sometimes makes sense, and of course collide with main layers, which is often what you would like. So just to get those a little bit more descriptive, we can go to project settings, general, search for layer names 2D physics, and I will call the first layer player, and second one we'll call, I know, ground. And now if I hover over it, you can see that instead of just layer 3, I get information that this is ground layer and it collides with player. So just to make sure that our player exists on the correct layer, I will click on it and find collision object to the collision, and I can see that it exists on layer 1 and it collides with layer 1, which is not correct. We can have those collisions register either on a tile layer or in a player, it doesn't matter, but to have them set up symmetrically, what I like to do, but it's again not required, is to have them set like this. So I know that player exists on layer 1 and collides with layer 2, and on the other hand I can see that these are set up symmetrically, right? And it kind of makes sense because I can now register to information about collision on a tile layer or a player, okay? And we will actually handle this in a player script. So let me open the scene and open the script, and this information is going to go to us from the in the player script, sorry. So first thing we have to do here is to check for collision. I can add a region to it if I want, and a region. And to get that information during our slide movement, right, because we use move and slide, I will just say collision get last slide collision. And here I could do additional things like checking what I am colliding with, right? But the in case of river ride, this is pretty simple because it does not matter what you collided with. If you collided with something, you should explode. Okay, so I can just say if collision not equal to null, just explode, or for now we'll print explode and we will return. Okay, which will prevent us from running all of the movement code. So let's see this. I will run the game and I do not get any information about collision as of yet. And why is that? Why we do not get any information about the collision? Well, let's see. If we go to debug and we'll check visible collision shapes and run the project now, you can see that we have a collision shape on our player, but we do not get automatically any collision on our layer. We have to paint that. So that's where we were at the start. With a main tile layer selected in our main scene, I can go to a tile set at the bottom and now select physics layer 0 and start painting on our ground. So I can just click on those, and for these I need to adjust the shape a little bit. So let's move those points down, click again, and then I can click on this and rotate it, I flip horizontally and click again to confirm. Click here, flip vertically, and again flip horizontally. And even though they are not perfect, this is fine enough. Also, we need to do the same for those shapes. And since this shape is quite different than the other one, I can just go to reset to default shape and adjust this as needed. And now I will just click and flip horizontally, click and flip vertically, and click and flip horizontally. Okay, and now if we run our game with those painted in our tile set, remember this is in a tile set, not in a tile map. If I run the game with visible collision shapes, now I can see that we have those, right? They're not so green, they're partially blue. And now if I move into one of our tile parts, I will stop the movement and have that explode printed. So going back to what I said about the collision masks, let's actually click on our player and disable that mask and see what happens. Even though we have defined our tile layer, physics layer, they're no longer colliding. We disabled that because we said that currently our player should not collide with anything, right? Only if we have proper collision mask set, now they will collide properly. Okay, so one additional thing that we can do is to actually write our explode code. So let's see. Instead of printing the explode, let's go to our player scene. Let's go to animated sprite, and we will add one simple animation here. So let's just go to create new, add a new animation. Let's call this explode. Let's go to our sprite sheet, but we'll choose free smoke FX pixel. I believe these are also 16 by 16, or no, maybe these are, I don't really, oh, it's not that, it's that size is 16 by 16, no, it's bigger, it's 32 by 32, no, it's 64 by 64. Yes, I believe that's correct. And now we can select any kind of explosion that we'd like to represent the explosion of our aircraft. I'm gonna go with that one. It looks cool. I will change this to not be looping, and I will change the FPS to 32. Going to 2D and scrolling out, I can see how that's gonna work. Right, it's rather fast. play static animation from the start. I believe that works. You can choose any other. And yeah, let's actually run it and change it a little bit. So we'll call explode function, and let's write that function here. So we'll be creating a new custom function and calling this explode. And let's see what we need to do. We need to get to animated sprite 2D and play explode. We need to set physics process to false, and let's do this for now, and let's set the velocity to vector to 0, and let's see how this looks. So I'm hitting that and I'm playing it. Of course, this is some kind of leftover that I don't want. So we'll do two things to finish this section. First is I need to know when the animation stopped playing, so I can go to animated sprite 2D and check the node tab and search for animated finished signal and connect to it. And let's check whether the animation that was playing is equal to explode. If it was, let's just QE free and get rid of that node. Basically, this means delete. Okay, way better. Also, the explosion really shouldn't be white. I can change the color of the sprite being animated on the run by simply calling animated sprite 2D modulate, and let's find some kind of nice red color, maybe crimson. Let's see how this looks right now. So just pressing left and or right, and now it explodes in red, which is kind of cool. And this is going to be our setup for collision and explosion. And I will see you in the next section. Okay, so in this section, what we'll handle is the missile and shooting system. So let's actually start by creating a scene, new scene, and that is going to be our missile scene. So let's search for area 2D, and we need to add some basic stuff like sprite 2D, and let me turn on mouse highlighting, and we will add the collision shape. So let's search for collision shape, go to 2D, and for sprite 2D in the inspector texture we can quick load. We can quick load this from sprite sheet, and as you can see it will load everything, but we only care about that part, which is the missile. And to limit the display to only that, we can use the region. So let's enable that, and let's edit the region. Let's snap mode to pixel, and we can set this by just dragging those in and scroll to zoom, and that's the part we are interested in. So let's close that, and as you can see we are actually displaying the missile. So let's add a shape. The rectangular shape is fine. Let's just drag this to actually make it match what we have here. So this is good enough, and we can save it into scenes and call this missile PSCN. And what we need is a script for that. So let's click and create new script, going into scripts, open and create. Perfect. Let's start by adding a class name here. And let's set the missile speed, and I'm gonna do export var missile speed, and we can set this to 400. When it comes to movement of a missile, this is going to be very easy. We'll just say function process delta position y equal missile speed times delta. Again, just to remind you, minus for y means up direction. Then basically what we will need is to decide what to do. If we hit any of the body, so let's actually find on body entered, we just want to QE free. There's also another thing where we would like to delete that missile. Basically, when it goes off screen, meaning it leaves the camera bounce, we also would like to delete it because we're not interested in what is happening to our missile when it's off screen. And to do that, we can use another node, which is visible on screen notifier. Okay, and also we will adjust this to match the shape of our missile. Okay, and then we can find screen entered signal. So let's connect to that, and I can just say QE free. And that's it for now, since we don't have our enemies defined yet. That's all the code we need for now. Well, we have to, of course, use that scene in our player. And what we could do is, add that code into the functions we have already. But I tend to try to have everything nicely separated, so I'm gonna add a new empty node, which is just a node. Now we'll call this shooting system, and we'll keep all the logic regarding the shooting in here. And actually I will make this a node 2D, so I can right click and change type and switch to node 2D. And then I will also add a marker 2D, which is going to be our missile spawn point. So let's call it that. Of course, it's hard to tell with that animation where the tip of our aircraft is. So let's go to animated sprite 2D and let's switch to default. And now with that, I can move this up here. And this is going to be our missile spawn point. And you might wonder, why do we need the shooting system to be a node 2D? Well, we're doing that because if that would be just a node without a transform, it wouldn't move with the player, right? And I need to move it with the player to adjust for our movement in a game. It would always be stuck like in the starting place, which we don't want. Let's add a new script to shooting system and switch this to scripts, and let's call this shooting system. And let's hit create. What we need here is, of course, the class name and a reference to a missile scene. So let's go to our scene folder and let's grab and drop the missile, and I'm gonna call this missile scene. What we can do is grab the reference to the missile spawn point, and then we will work with two things. We need a variable like a flag tracking whether we can shoot, because in original game, player can shoot only one missile at the time, so you can't just like spam the missiles indefinitely. So can shoot is equal to true, not true, true. Then let's use input event to check whether we can actually spawn the missile. Is action just pressed? Let's find shoot action and can shoot. And now what we need is the new missile scene, and we need a colon here. Missile is equal to missile scene instantiate. Let's set it, oops, just instantiate. We need to set its global position to missile spawn global position. We need to add it to our node 3, so get 3 root add child missile, and whenever it's about to be removed, let's connect to that signal and just say on missile destroyed, and we'll just trigger the flag here. And can shoot is set to false. So once you shoot, what we are doing is we're creating new missile, putting it in missile spawn point position, adding it to our tree, and we are listening for the node, the missile node, to be destroyed by listening on tree exited signal. And of course we set the can shoot flag to false so that user cannot spam the space to spawn multiple missiles. So on missile destroyed is going to be very simple. We just turn the can shoot to true. And that should be basically all we need for shooting. And I believe there's one problem. You can see that the missile is appearing and disappearing immediately. That might be due to the fact that we did not specify the proper collision for it. So let's see. Collision layer, it's not a player, it should not collide with the player. And let's create new layer here. So going to project settings, we can go to 2D physics and let's add missile and enemy layer. So this is going to be missile, and it should collide with ground and enemy. Let's try this again. Yeah, now you can see this is working properly. So this is our shooting system being implemented right now. Yeah, I guess we'll continue in the next section, and I believe we will have a brief pause from programming, and what we'll do is we'll add a decoration layer to our game. Okay, so in this section, we'll improve the look of our map a little bit by adding some decorations. To do that, I will create another tile layer. So let's go to add tile and search for tile layer. I will call this decoration tile layer. Let's put this below that one, and to keep it more organized, I can left click here, sorry, add empty node and call this tile layers. Bring it here and move those there. So as you can see, I'm treating this empty node as a folder or I don't know, box for other nodes. Okay, so let's click on decoration layer. And when it comes to tiles, I'm gonna use the very same tile set that I have in the main tile layer. So what I can do is go to main tile layer, go to tile set, click on this chevron here, and click save as, go to assets, new folder, tile set. Well, we'll only have one. Let's see, and I'm gonna call this just tile set. And then whatever change is going to happen to that resource in main tile layer will be reflected in decoration tile layer, because we will be using the very same tile set. Perfect. So as you can see, we have a few things here. We have houses and we have trees, and I can just click on that and go to decoration layer, and I should be able to, oh yeah, need to switch that, and I should be able to just put it, and I can place it like here and there. You can go crazy with that, of course. But I'm just going to click randomly in a few places here and there. And then of course we can do the very same thing with houses, just to add a little bit of decoration to our game and make it feel more alive. Yeah, so again, you can go crazy with it. And if you don't like placement of any, you can just right click to remove it. So let's see how that looks. Okay, it looks kind of nice. It's gonna look better after we remove the collisions, so we can do that. Disable visible collision shapes and rerun this. Okay, that looks pretty nice. One thing that we also need to add when it comes to decoration is the level separation. So this narrow gap here that you can see typically means the level ends here and another section or level starts, right? And these are separated by road and a bridge. So if you go to decoration layer time map, you can see that we have a part of the road here, and I will use that to basically place it across the level, and that's where our bridge is going to be. So the bridge itself is not going to be a part of the time lap because it's gonna be interactive. Like, you basically need to destroy it to finish the level in the river ride. So we'll add this later. So yeah, this is how it looks. We could also add one here if we'd like to. So let me just grab that one maybe. Oh, that's the wrong layer. It should be in the main title layer. Right, we can add it here and add it here and here and here, and we can go to decoration layer. So as you can see, switching between the layers is really easy right now. Very cool that they added that. And I can just create a line here. As you can see, I'm using the line tool, and we have our roads added to the game. So let's save this. And now as we go across that, we can see that we have our road in place. Perfect. So I believe in the next section, it is a time to start working on our enemies. I'll see you there. So in this section, we will handle our enemies, and there will be three types of them: the ship, the jet, and the helicopter. And they're similar but different. They have different sprites, they have different collision shapes, they may have different explosions color, speed, or points. But the basic functionality and behavior are the same. And the situation where one entity or few entities in your game have similar but different behaviors or looks is a great situation where you can use custom resources. So we'll use custom resource to define some properties of our enemies, and then we'll use that resource in a singular node to basically configure our enemy. So to do that, let's go and start by creating enemy configuration script. So in scripts folder, I'm gonna click and choose create new script, and I'm gonna choose enemy config as a name. This isn't going to be attached to any node, and it's not gonna extend the node itself. It's gonna extend resource, and this is just like a static configuration for our enemy. I can add a class in here, enemy config, and then I will export few variables here. So let's start by exporting enemy collision shape, which is going to be rectangle shape 2D. Export enum, it's going to be the type of our enemy, and it's going to be either ship, jet, or helicopter. And this is going to be enemy type of string ship. And this is going to basically create a drop down for us to choose the enemy type. Then we'll also create export var explosion color of type color, export var speed type float, and let's set default value to 50, and export var points, and let's set this to integer 75. So with that basic configuration, we can now create concrete types or implementation of that configuration. So in let's see, in the main folder, let's create new folder and call this resources, and let's create new folder here, call this enemy configs. Okay, here and here, and let's create new resource, and this is going to be just resource, and I'm going to call this helicopter config. If we take a look at it in the inspector, you can see that there's nothing really important here, but that's gonna change if we set the proper script, which is going to be enemy config. Now I can, as you can tell, create some concrete implementations. So let's take a look at our ship. So this is going to be all default, but the explosion color, let's make it nice and red, really saturated red. Okay, that looks good. The one thing that we need though is enemy collision shape, and what I would do is just create the enemy and load different sprites and create matching collision shapes. So let's do that. I will go to scene, new scene, choose other node, search for area 2D, add the typical nodes that we need, which are animated sprite 2D, and we also need collision shape. And let's not make it a child of animated sprite. Let's name this enemy and save that scene. So going to scenes, enemy TSCN. Okay, let's try and create some animations for that. And we are creating animations because our helicopter is actually animated. So let's click on sprite frames and load from sprite sheet. And this is assets, sprite sheets. And remember the size is 16 by 16. And now I can, what I can do is start with the helicopter. And I can grab these two and add to frames. So let's see how this looks. Wonderful animation. And let's call this helicopter. And now for that one, I can create matching collision shape. So going to collision shape, new rectangular shape. I can set it to match the shape of my sprite. And then I can save it as a resource. So go to save as. Going to resources, I will create new folder and call this collision shapes. Collision shapes. And I'm gonna call this collision shape helicopter. So this is done. Going to sprite frames again. I will add new animation, even though it's one frame only. And let's search for our jet. Okay, I will call this jet. And going to collision shape, now I will create new collision shape. And also make it match this animated sprite. I believe this looks good. Let's go to save as, CS, jet. And finally, let's handle our ship. So go here, and this time I'm gonna change the size to 32 by 16. And as you can see, I cannot select the ship, but if I make a 16 pixel offset, now I can. And let's go to collision shape and create new rectangle shape. And as you can see, this is kind of irregular and I cannot place it well enough. I'm gonna say this is good enough. Okay, and maybe move it. Can I move it right? I believe this is good enough. So let's go to save as, collision shapes, CS, chip, and save it. Perfect. So with all of that, I can go back to my configuration. So enemy config, and in helicopter config, I can now go to enemy collision shape and quick load CS helicopter. I can create new resource here and call this jet config. Load the enemy config and set it up properly. Enemy type is jet, collision shape is CS jet. The explosion color, I believe we can go with something like yellow. Let's add more value here, and maybe a little more orangey and a little bit brighter, something like this. I can increase the speed to 125 and point to, I don't know, 150. And the same is going to happen for the ship. This is ship configuration. So collision shape is CS ship. Let's see, this should be helicopter, of course. So helicopter, jet, ship. The explosion, I don't know, let's make it like dark, I don't know, orangey color. Right, so something like that. Speed we can put at, I don't know, 80 and and points like 100. And we have our configuration of our enemies done. So with that, in the next section we'll actually make our enemies work. So with our enemy configuration done, what we can do now is actually write a script for our enemies to make them move and be able to shoot them down. So let's go into our enemy scene and let me turn on mouse highlighting. And I will attach a new script, enemy script. That sounds good. Going into scripts, open and create. So let's start by creating a class name. And let's export a few things here. So we'll have enemy config as a variable here, and it has enemy config class. So we'll just drop the configuration that we created in the previous section to bootstrap our enemy. We'll have, let's see, we'll have switch starting direction flag. And we will need the references for animated sprite and for collision shape. And let me move this out of the way. And also direction, which we'll set to 1 indicating right direction or -1 indicating left direction. So let's start by working on our ready function. The collision shape for our enemy should of course come from the configuration. If we would like to switch starting direction because we would like to go left instead of right, we'll just change the scale X to -1. When it comes to animation of the sprite or the sprite being played, we can just say animated sprite 2D play, and instead of choosing one of these by hand, we can just again use our enemy config. There's one thing though, when playing the game, you will see that helicopters, they turn and switch direction, but the jet is different. It's like floats above the ground, and to do this, we need to check whether the enemy config enemy type is equal to jet. And if it is, then for our enemy, we need to disable the collision with the ground, right? Because when it comes to what we'd like to collide with, let's see, the layer is 4, and it should collide with ground, and it should collide with a player, and it should collide with a missile. Okay. But for jet, we disable the ground collision. So set collision mask value 2 to false. So it won't collide with the ground. When it comes to movement, again, this is going to be rather simple. We'll just say function process if should move position x speed, and we'll get our speed from configuration. Let's give it a default value, and then in ready we can just grab this from config. Speed times delta times direction. Okay, cool. Then we also would like to be able to turn, and we don't have that flag, so let's create it. We will start with true. And why do we need that flag, right? Let me maybe explain this to you. So if this is our tile set left and right, and this is our enemy, it should move left, and then hitting the edge of the tile, it should turn back. But if it gets hit by a missile, right, we would like to play the animation of explosion but disable the movement of enemy. That's why we need this should move flag. So this is all good. Then what we need is information from our area on body entered. We need to check whether what we entered with is a tile map. So if body is tile map layer, what we'll do is just set the scale x to multiply by -1, and direction also switch it by multiplying times -1, right? And this basic setup should allow us to go to main and create some enemies. So let's see. I will add child node, empty node as a folder for our enemies. And let's create or rather instantiate enemy. I'm gonna call this ship enemy. Then another one, this is going to be heli enemy, and then another one will be jet enemy. Okay, and they all behave the same for now, and they all render the same. So let's go to inspector and let's start with quick loading ship configuration enemy, and we'll say that it should switch starting direction because default direction, as you can see, is pointing right here, and I would like it to go there. Then helicopter enemy, right, and we don't need to switch the direction. And then to test our jet enemy, I will place it here on the tile map ground. To remember, it shouldn't collide, it should fly over. Yeah, let's try this. Okay, this has to switch direction, right, because it goes opposite way. So let's try this again. Okay, now it looks good. and it flies over. Okay, so the next step is going to be actually being able to shoot our enemies. So to do that, let's go back to our enemy script. And let's see, we should create explode function here. So this function is going to play whenever missile hits an enemy. So should move should be set to false. The animated sprite 2D modulate should be set to enemy config explosion color, and we should play the explosion. Play. Do we have that defined? Explosion. Let's see real quick. Not yet. Okay, no worries. Let's add animation explosion. And with that, we'll go to assets. I believe that was 64 by 64. I believe this is 64 by 64. And let's choose any explosion that looks fancy enough. Maybe this one. Let's add it as explosion. Let's see how fast it would play. Yeah, it needs to go a little bit faster. So let's do, I don't know, 15 FPS. Okay, that's good enough for me. You can choose basically any other explosion that you like or you find on the internet. So going back to our script, I made a sprite to display explosion. I believe that's almost sorry, almost all. The one last thing we need is to actually free the node. So going to animated sprite 2D, then going to node. Let's find animation finished, connect, and connect here. Of course, we need to check for the animation name. If animated sprite 2D animation explosion, I believe is the name, we need to QE 3. And if you try to run it, it is not going to work yet because we did not write the correct function in missile, I believe. Let's see. On body entered, yeah, that's not gonna be enough. We need to connect to area entered, I believe. So let's connect to that. And then we can just do checking for the class. If area is enemy, we can just call area as enemy explode, and then of course we need to QE3 ourselves, meaning the missile. Okay, let's see where we can actually hit this. Yeah, the problem is it plays on repeat, so not ideally what we wanted. So going back to our enemy, we can go here and we need to disable animation looping. So let's click that. And now they're gone if they're hit correctly. Okay, perfect. I believe that's it when it comes to enemies. And of course, we have only those three, but since we have those three types, we can actually organize it a little better. Let's add empty node and call this ship enemies. Let's add another one, call this jet enemies. And let's add another one and call this heli enemies. Move it here, and now we can just duplicate and move star around. And again, you can place as many as you need with the configuration that you want. Remember that you can make them go the other way if you want to. And I will place another ship enemy also here. Remember, in the real game you would plan placing those way better, right? But I believe this is all we need for that section. Okay, perfect. The next step will be to add a little bit of UI and start working on our fuel or power. And I'll see you in the next section to do that. Hello and welcome into this section where we will work on building the UI. So as you can tell, there's no information about player lives or no information about current level of fuel or power, because we're trying to be original here and we replace the fuel with power. So let's fix that. Let's create scene, new scene, and choosing the other node, I will search here for canvas layer. And this is just a layer to basically use for UI, which is rendered on top of everything else. So choose that. And I will rename it to UI and save it. Going to scenes. And let's name this UI TSCN. This is fine. Okay. So we have that set up. We will need a few things here. Let's start by creating the simplest thing, which is going to be a game over pop-up. So let's search for center container. And I will call this game over view. And I will just simply add a color rect here. And let's give him a proper size. So going to there's no transform. We need custom minimal size to be 200 by 200. And let's make sure it gets centered in our screen. I don't know whether you can see it correctly, but there's this thin blue line, which is like the edge of our screen. So it's hard to see because of the background color, right? But this is basically the border of our UI. And in here, I will just simply add a very simple label, nothing fancy here, but I encourage you, of course, to go crazy with it. And it's gonna just say game over, and it's not visible. So let's go to the theme overrides, colors, font color, check it, and now we have something rendered here that will indicate to the user that the game is over. Of course, we would like to have this hidden at the beginning. Let's focus on the main part of the UI. So let's go to add child. We find another color rect. Move it up because it's way important than the game over screen. So it should be above. And I will call this control panel rect. We need to set it at the bottom, glued to the bottom, and we need to give it at least some height. Let me see, what did I use here? 58. Oh, sorry, 58 should be good. And I'm gonna change the color to non-threatening grayish. Okay, let's add it to our main screen already and see how that's going to render. Let's try and run it. Okay, looking good, good enough for me. And it always stays at the bottom. Perfect. So we need to add few things there. This is going to be very simple UI. I encourage you to make it more beautiful. So we will need a label to display the information about lives. So I'm just gonna write lives free for now, and I should be able to freely set this somewhere around here. If you'd like to have more control over where it is placed, you could always use HBox container to place it properly. But since it's so simple, I'm not going to do that. Let's call this lives label. Then let's add points label. So searching for the label here. Here we go. Bringing it on the other side. Let's call this points 0 at the start. Okay, and then the main thing that we need is the power meter and the power indicator, and these are going to be texture rectangles. Okay, so let's bring it here so that it is visible, and this is going to be power meter. I hope that's the correct name. I'm going to click load. I have fuel meter. As you can see, it is a little bit squashed. So we will ignore the size and leave the scale as it is. And since I know the dimensions of it, I can go to transform and set the proper size already. And I know this is a proper size because these are the dimensions of the texture. Okay, I could probably set it here in the middle, maybe not at the very bottom, but I can just drag the green arrow to place it a little bit higher. And then the other thing that I need to add is another texture rect, which is going to be power indicator. Let's grab it here. Okay, and I'm going to go to quick load and get the fuel indicator. Again, I can set it to ignore size and scale because I know the exact dimensions of that texture. So going to transform, that's gonna be 5 by 20. Okay, and I will place it right here. Okay, then it's a matter of programming the movement of that fuel indicator according to our power level. Okay, so with that set up, I can already start working on a script for our UI. So let's click and add one, and I will be going to scripts and saving it here. Perfect. Okay, so what we need here are a few things. One thing which we always do add is class name UI. Then let's export a few things here. We need minimal power indicator X position, is going to be float. We need max power indicator X position is also going to be float, and these are the values between which our indicator is going to move from left to right. Then we need power decrease factor, so how fast this goes down, and I will set this to 1. And then we need some references. So this is going to be power indicator reference. This is points label. So let's grab this. And then there's lives label. And we can also get the reference to game overview. And then we need few things here. One will track the total points here, and you might argue that this is not the place to keep total points, but since it's very simple, we'll leave it as that. What we could actually do is add some kind of game manager node to track all the points and then pass those points into UI, and also to track lives, but we'll keep it here just for simplicity's sake. And then we need power indicator X position, which is like the current position representing where our power is. Okay, so what we need is a ready function. Let me get some space here. And power indicator X position is equal to max power indicator X position, because we start at the full power. Then for the points label, we'll make sure that the text gets reset. You can do that with string interpolation. This means we're searching here for integer to be replaced with that value. Okay, then we'll create a function to set up the power, or I don't know, kickstart power, which is going to be max power. Now we'll say that the power decrease factor is equal to max power indicator X position minus power indicator X position divided by max power. So how fast this should go down is based upon the maximal and minimal position of indicator divided by maximum power. Then we need change power indicator function, and it's gonna go for a direction, because we can go from left to right when it's increasing, or right to left when it's decreasing. And we need to pass a tween time here, because to make it kind of smooth we will use tween. So let's create a tween property power indicator position direction times power decrease factor tween time. And what is important to make it work, let me just move it back, we need to start from always from current position and always as relative, right? And this just indicates that the final value will be used as relative value instead. Okay, so since we don't want to calculate from like starting position or any other position, we always like to calculate how this should move from current relative position. And we can also already write very simple show game over screen game overview show. And if we run it, nothing is going to happen really right now, because we did not plug it to any real data in our game, but we'll do this in the next section. So I'll see you there. Okay, let's handle the fuel/power implementation right now. So going to player scene, and let's stop the game from running. I will add another system here. So going here to child node, I will select empty node because we don't care about the position of this node. This is just, you know, to split the responsibilities in our code. And I will call this node power system. So let's create power system GD and rename this to power system. We will need two timers here, so let's search for a timer. And let's name these power decrease timer and power increase timer. So one will run basically all the time to decrease the level of power, and the second one will only run when we are over the power station. So let's go in here and let's start by creating a class name. Power system. Perfect. So let's set some variables here. So we have max power, and I will set this to 30, and minimal power is of course 0. Also, we need to track the current power. Since this will directly communicate with UI, right, I would like to have a reference to UI here, and we can find it rather easily using the path. So this is going to be, you can see that we have a reference to root here, so we'll use this. So root main, because here we have our main scene, and then we have UI, so we can reference that. Root main UI, and then we'll get the references to power decrease and power increase. What we will do is we will also have references to our timeouts. So let's go here, and we need power increase and power decrease timeout. So going to node, I can find that timeout signal and connect to it. So on power decrease timer timeout and power increase timer timeout. So going here, connect power increase. Oh, but I added them to a wrong place. I don't want them into our player, added to our player, but I need them added in a different place. So connect again, and this time we're searching for power system and choosing that one. So again, timeout, connect, search for power system, and now this is connected properly. Okay, so I believe we have almost everything that we need here, so we can finally start coding. For our ready function, so what should be done at the beginning? Our current power should be set to max power, and we need to call UI setup power of max power. Okay, when running power decrease timer timeout, we'll decrease current power by -1. We will change the power indicator with vector. Since we're decreasing, we should go left. And as a tween time, we use power decrease timer wait time. Okay, so going here, I can set this properly and say that this should go 1-0 and it should auto start. Okay, and then for my power increase timer, I will set this to 0.1 and I will not auto start. Also, when we are decreasing, if current power goes to 0, we should get parent as player, because the parent node of this power system is of course the player, right? This is the power system and here is its parent. And I can just go here and call explode, because, well, game is over when we explode. On power increase timer timeout, if current power is less than max power, we say current power plus equals 1 and UI change power indicator to vector 2 right power increase timer wait time. So let's see whether this works when it comes to decreasing our power level. I will not move. Oh, and nothing is happening yet. So let's see what is wrong. We have the power system, we have the timeout. Let's see. Let's print current power. And I can see it's going down, but the indicator is not moving properly. So let's try and fix that. And I can tell that this is not moving because we properly did not set max power indicator and minus power indicator. So going to UI, I can see that in the main UI, these are defined as 0. And let's see what the values should be there. So selecting that one, I can see that this position is 639, and then I would like it to go to minimal of around here. So this is 501. So going back to main, I can set those values here. So 501 is minimal value, and then 639 is maximum value. And that should allow us to move that properly. And as you can see, yes, it is moving down in a gradual way, and it should blow us down out of the sky when it goes to 0. So let's wait here a little bit to make sure that the game is actually going to be over when we do that. Yeah, the game is over when we do that. Okay, perfect. So going back to our player and power system, we will also need a few other functions. Let's see. We'll need functions to increase and decrease, but when we are exploded, right, we should tell our power system to stop its timers. So let's get the reference to power system, and on explode, stop timers. So let's add that function. Now we'll just say, do we have the references? Yes, we do. We can stop both of them just to be sure. Okay, so we have that working. The power is now decreasing properly. And what we need to add is the ability to restore our power. So, and I think there's one other thing missing, is that we're not colliding as a player with the enemies. So let's try this, and let's try get being blown up by hitting the enemy. Still not working. This is probably because the enemy is not set to collide with the player. So let's check that. Player, we're enemy and we're colliding with the player. Okay, but we are probably not checking that collision with the within here. If collision is not null, because enemy is an area, it's not going to be available here. So instead, let's go to enemy, and if check for body is a player, what we can do is call explode, and body as player explode. That should allow us to register the collision properly. Yeah, perfect. So that fixes that issue. And in the next section, we'll handle our power station. So I'll see you there. Okay, let's handle our power station. And this is going to be rather simple. Let's go to scene, new scene. And as always, we'll use area 2D because, well, this is enough. Let's call this power station. And let's save this already as a power station here. We will need, we could use animated sprite 2D again, because we will be playing animation here. So animate that sprite 2D. And of course we need collision shape. I'm going to animation, new sprite frames, and opening that. We will need a default, which is going to be just that one. And let's see, we have a power here. So to select this properly, what do we need really? The size is going to be, I believe, 16 by 16 still. And as you can see, this might be a little bit too much. We could probably fix this with offset. So let's see. Oh, this is X offset, sorry. 8 pixels. A little bit too much. 6 pixels. Let's try and adjust this 7. 8. Well, that could work, but we need to increase the size to 32 then. And then increase this. And I believe 23 is okay. We can add that frame. Let's zoom to it. And then we need to add, of course, the explosion animation because it can be destroyed. So we're not going to be looping this. Set explosion animation FPS sorry, to 15. Search for the explosion and change the size to I believe this is 64 by 64. And let's choose this one, but any will do. Going back here, we can now add the collision shape. So let's drag this here and this one here and do it like that. And we have our power station set up. Let's set a script for it. This is going to be rather simple, I hope. Okay. As always, define this as power station. And we need to provide some information here. Let's grab the reference to animate the sprite 2D. Okay, we have this in already. Let's see. We will need the explode function because it will be able to explode. And we'll just play explode. What else do we need? We might need to do to listen to finish of that animation. So let's see, animation finished. And again, we just need to queue it here. Perfect. And then we need to listen on body entered and exited. So let's connect these. In both, we need to check whether we are a player. Or basically, we wouldn't need, because we could set up the proper collision system. So maybe we can skip that. So let's set the collision layers as we want it. So let's see, the layer is should power station and the mask should be a player. Do we have players power station defined? We do not. So going to project settings, and here let's search for physics and search for layer names. And we have our layer names, and as a layer 5 I'm going to add power station. Perfect. We can close that, and now I can say that this is a power station and it only can interact with a player. So I can say body as a player, and I don't need any other checks because just looking at our layer and mask setup, I know that this power station can only interact with a player. I can say get node, and I will find power system node within a player, and I will call start power increase. And in on body exited, it's gonna be pretty much the same, but I'm going to call stop power increase. And of course, for it to work, I need to define those functions. So going to our player and power system, let's add these functions. So basically, we'll just start and stop the timers here. Start power increase will say that power increase timer starts and power decrease timer stops. And on the other hand, stop power increase will say that power decrease timer starts and power increase timer stops. And that's basically all. The one thing that we're missing to make sure that it is working is to check whether area is power station and make sure that our missile can interact with it. And if it is, I'll call area as power station explode. And this is of course in our missile script. So we need to test two things: whether our player can actually increase its power with the power station, and second thing is going to be whether we can destroy the power station. So let's move this out of the way and let's run it. First thing, can we destroy this? Yes, we can, and it does not QE3. So let's go to power station, and this is not looping. This is explosion. Let's go to our script, explosion. A typo here. So it should, oh, sorry, and it should play the default animation by default. To play on load. Perfect. And can we increase our power here by flying over it? And it seems we can. Okay. We could of course place the second one a little bit further down the road. To make sure we can actually do it. So we're losing fuel or power, however you'd like to call it. And we can increase it. Perfect. So yeah, this is our power station done. The next step I believe to do is adding the bridges to our game. So I will see you in the next section. Okay, so in this section we will handle bridges. And bridges in River Ride work as a start and end of a level, and also as a checkpoint. So let's create new scene, and it is going to be, you guess it, area 2D. Let's call this bridge. Let's save it in the scenes folder, and let's start working on it. So I will start by adding animated sprite 2D. Okay. Let me see. And we will go to animation, sprite frames, new sprite frames. Open it up, and let's go to sprite sheet. And let's try and adjust to grab these. So 32 by 32. And as you can see, this is a little bigger than 32. So we need to adjust this. Let's see, I believe that's gonna be 38. Oh, sorry, not that value. 32, 48, and then we probably have to adjust the offset. Perfect, and we can select that. So this is going to be our bridge, and let's already add this to our main scene. I will create new folder node and call this bridges, and let's instantiate child node as a bridge. So let's be sure to grab it, and let's see how many do we need, right? And this is just to get some information about how much do we need. 3 and a bit, right, to cover that. So let's go back to our bridge scene, and let's see, can we do this with repeat and searching for scale? Well, this stretches it. Well, repeating it will do us no good. So instead, I'm just gonna copy these and place them next to each other. Let's see, we need a 3.5 to cover these. Okay, let's go to main. And what is important, because this is now bigger than our gap, is to have those bridges rendered first before tile layers. And now we can adjust that rather easily and place it where we need to. So about here should be fine. Okay, so now I can add a collision shape to it, and it should cover basically the whole width. So let's adjust for that. And bring that here and here. Perfect. Then, since this is using the very same sprite frames for all of those animated sprite nodes, I will save this as and go to resources, and let's see, bridge is fine. And then I can just add another animation, and that's going to be explosion animation. These are 64 by 64. And let's see which one. This looks fancy enough. Oh, and we should create a new animation for that. And that does need to loop and should play on auto load. So let's call this explode. Add the proper animation. This one is good. Yeah. And then let's load those. Oh, they're already loaded. Perfect. Very nice. So now we can explode that one. And then we can start playing with our code for our bridge. So let's go to script, open and create. Let's start by adding class name of bridge, and we will emit two signals here: destroyed and set new spawn point with a spawn point of vector 2. And what we need here is a reference to an array of animated sprites. So already var animated sprites is going to be equal to animated sprite the array. And then we can just grab all of those. I mean, I don't need reference here, but I need the path. that should be this one, and the last one is this one. Let's see, expected type for collection after. Oh, is it this syntax? Oh, let me check that. Okay, so I believe the type will be inherited here, or at least we can hope so. But we can grab all those nodes and put them into an array like this. So with this solved, what we need is information about whether the bridge is destroyed, and set it to false. And then we need explode function. Okay, so what we need is to do something for every single animated sprite. So let me think. For animated sprite in animated sprites, what we need is to set modulate to something nice and red, and to play explode. And after all of this is done, we need to say destroyed emit and say is destroyed to true. And already we'll listen to animation finished for each node. So for animated sprite in animated sprites, animated sprite connect, and this is, I would really love to get the autocomplete here as animated sprite 2D connect, and the signal should be, let's see, animation finished, animation finished, or I believe this should be a string, and then we will do on animation finished. It is not declared, that is correct. Let me hide this. We can add that below. So function on animation finished, if animated, if we don't get the information about animation here, right? We can bind that argument though. So the problem is that we're looping here and we don't know to which sprite this is connected. But this can be solved in a few ways. So let's do inline function. And here then I can reference animated sprite and say animation if animation is equal to explode, I can just say basically we need to hide animated sprite. So we don't need that since we're doing this inline. Okay, and that's, I believe, basically it. We have a explode, but we need to call it properly. So to check that, we need to set our collisions. So this should live in a bridge layer, which we don't have yet. It should collide with the player, and it should collide with a missile. So going to project settings, I can add as a layer 6 the bridge. And then in missile, if and this is area is bridge, I would just say area as bridge explode. Okay, let's see where that works at all. Oh, we need to start by avoiding everything, right? Okay, and then we're moving to the bridge. And I shoot and nothing happens. Okay, let's see. Is our missile set? It's not set to collide with the bridge. So let's just check the 6th input and that. Oh, I believe my Godot has frozen. Let me restart it real quick. Okay, let's try this one more time. And now it explodes. Also, the explosion is looping and it's too slow. No worries though, we can fix this real quick. So first disable looping and then increase this to 15. Okay, let's try and avoid every single enemy here. Now it's gone. Okay, perfect. So we have that and it is hidden. The one thing that we need though for our bridge still is to detect the body entered. So going here to node, we're searching for body entered and checking whether the entered body is a player. So if body is player, although no other body should collide, so maybe we don't need that check. We need to check whether the bridge is destroyed. If it's not destroyed, then body as player should explode. And this is like the situation where the aircraft crashes into a bridge. Else, if it is destroyed, then we should set new spawn point and emit as a self position to set a new spawn position, which we will do, I believe, in the next section. So let's go to 2D main and actually let's move our player up to the bridge so that you don't need to avoid all of this anymore. Okay, and let's see whether we can collide with the bridge if it's not destroyed. Perfect. Very good. And I believe that it is everything when it comes to the bridge. Next step is to actually handle the lives, the spawn points, and the points itself. So in the next section we will track the points for destroying every single stuff in our game. Let's handle points in our game. So basically every entity that can be destroyed in a game have a set of points that we can sum up and display in UI. This goes for enemies as well as the bridge and the power station. So let's make sure that every single entity has a point applied to it. So let's see. For enemies, this is going to be rather simple, because what we can do is just create a signal and call this apply points to UI with points set to integer. And when we destroy enemy, so when we do explode, I can just say apply points to UI and apply enemy config points. When it comes to call it as a function, oh, we need to emit it, of course. When it comes to a bridge, we can basically do the same, and we will, but we just need to specify those points. So we need to add that signal. Oops, it seems I did not copy it correctly. And we'll just get any arbitrary value and emit that. Let's say, I don't know, 125. And the same goes to a power station. And when it explodes, I can just do apply points to UI and I don't know, 150, because why not? Then all those entities will put into a group that we'll call something like, I don't know, with points. That's gonna be, we don't need it to be global, I think. Let's say with points. Okay. And then make sure that every entity that emit points is added to that group. Okay, then in our UI, we can simply say var entities with points is equal to get tree, get nodes in group with points, and we'll get this as an array. And I can say for entity in entities with points, I can say entity apply points to UI connect on apply points. And we of course need to create that function. On apply points, total points plus equals points, and points label text is equal to points %d % total points. And let's see whether that works and our amount of points increases. Okay, well, to test it with our enemies, let's bring our player down to the beginning of a level. So we start at 0, and I'm going to destroy this and try my best to shoot the enemy. You can see it is being increased. correctly, also when destroying the bridge, the amount of points increases. So you have that sorted and out of the way. So in the next section, we will handle lives and spawn points. Okay, let's handle our lives and spawn points. But first, let me correct myself and go to the bridge script. And I was struggling a little bit to remind myself how should I type this as an array of animated sprites. And I tried both animated sprite 2D like this, and also like this. And finally, I found out that this should be defined as an array of animated sprite 2D. So this would be the correct way to type your array for nodes or any other type. Okay, with this sorted out, let's go to our main, and here we'll create a game manager script to handle our respawning and our lives. I try to avoid using those godlike classes, but sometimes there's no other way. So let's go to our scripts, and I will call this game manager. I really try to avoid manager as a word, but because what does manager does, like, it's really not clear with that name, but I believe it is going to work for that matter. So class name game manager. We'll export the player lives, and I will set this to 3. I will get a reference to player scene. So this is going to be preload, and let's search for player tscn. We need a reference to a few things, one being PhantomCamera 2D, the other being the UI, and the current player. And then we need to find the first player spawn point. So going to main, we're starting here, and I can click on a player. Oops. And go to inspector, and in transform I'm gonna see this is my starting position, so let me copy this value and go back to game manager. So player spawn point should be can I just paste it? No, I cannot. But I can see it here. This is a vector2 of -2 and 40. Okay, so what I need to get is the reference to all the bridges. So I'll just grab this, and we have bridges, and I can get its children in case I have more bridges. So function ready, bridge nodes, let's call this is bridge nodes, sorry for a typo. Get children as array of bridges. Okay, and then array of bridge, of course. This is the class name. For bridge, in bridge nodes, I can say bridge set new I'm making so many typos today. Bridge. Okay. Set new spawn point. Connect on set new spawn point. And this is going to be rather simple again. On set new spawn point, we'll get the spawn point as a vector 2 and say that the player spawn point is new spawn point. Okay. Now, what we need to do right now is actually also already apply the lives to UI. So UI will create apply lives function and pass player lives. Perfect. So going to UI, I will simply write apply lives and say lives label text is equal to lives %d %lives. Wonderful. So with that done, I can go back to our game manager and expect this to run properly. Let's see. We have lives 3, and if I'm going to change it to 2, it should be 2. Perfect. So we have that. Okay. So now what we need is basically handle the situation when player exits the screen, right? So because this is when Q3 happens. So I'm gonna grab a player and say connect, and then signal name is going to be exited, and then on player exited. So let's create that function. On player exited, meaning we lost a life, we exploded as a player. We decrease the amount of lives, and then we say if player lives is equal to 0 now, we'll say game overview show. Okay, else we'll respawn player. So now respawning the player is going to be rather simple. We'll say that the player is player scene instantiate, and we need to get root get node main, add it as a child, player, set its global position to player spawn point. Oh, and that does not need colon. And set the PhantomCamera to D, follow target to player, and then once again copy that line to listen to when blowing up happens again. And let's see whether that works. So I'm blown up and I restart, but I believe that we should also remove all the points, or maybe not. Maybe we should handle those. Yeah, we should keep those between lives, I believe. We're destroying the bridge, right? And we're blowing up and we see game over. But what interests me the most is that whether we actually set the new spawn point correctly. So going to main 2D, I will again grab the player, move it up just before the bridge, run the game, blow this up, and then hit this. And now, as you can see, I'm starting right where the bridge was. So this works, but what doesn't work, I can say that our lives are still at 2. So let's go to main. We start with player lives 2, and this should go down, but we are not updating the player lives here, right? So on player exited, respawn the player, and also apply lives, player lives. And now we should be good with that. We blow up and we have life set to 1, and it brings us to the start of the level 1. Okay, we have that done, and this basically means we're almost done with the game. One last thing I would like to add to make the game feel more alive are the sounds, and this is the last thing we'll do in this tutorial. So I will see you in the final section. Okay, let's handle the sounds in our game. And if you go to assets, sounds, you will see that we have few here. We have shoot sound. Let me turn desktop audio on maybe. We have bomb explosion. We have thrust start, thrust loop, and thrust end, and this is thrust start. So we have to basically program correctly all of those sounds, with this 3 being the hardest because they can overlap each other, and we need to introduce some code to set them up correctly. So let's start with that. Let's go to a player, and we'll need a node to play this, and then this is going to be audio stream player, and here we will need a reference to that. So let's grab this audio stream player. Perfect. And we will need 2 variables to control the start and end thrust sounds, and that's going to be played start once, set to false, and played end once, also set to false. And with that we can start working. We will go to where we do acceleration and deceleration, and if we did not played start once, we'll say that the played start once played start once is set to true, and then we will play a sound. So we'll create a play sound function, and what we need here is the reference to all the sounds that we need. So I can create a region here, or I could create a group, right? So maybe let's do that. Export group sounds, and then close the export with that was empty string, and we need export var first start stream is going to be audio stream, then loop, then end stream, and then explosion sound audio stream. Perfect. So now going to player, we have, let's see, we have movement, and where are the sounds? Oh, it's because the function play sound cannot be found, so it cannot comply. Okay. Play sound stream audio stream, and for now we just make it pass. Okay, so that should work now. Let's see. Still nothing. Too few arguments. Okay, well, we can pass the start here, and now it works. And let's make this capital. Now it was able to compile the script and we have everything. So let's see, we need start, loop, and explosion. Okay, and with all of that we can actually write the function. So what we need here is to first check if audio stream player is playing. If it does, we need to stop currently playing sound, assign current stream to audio player stream, and say audio stream player play. We also need to listen for a specific signal here, and the signal is finished. So let's attach that signal here in our player script, and basically we need to loop the looping stream. So if audio stream player stream is equal to trust loop stream, trust start stream, we need to start playing sound first loop stream. And if audio stream player stream, if we finish playing the ending, so first end stream, we need to set the player end ones to false and played start to false. Okay, and this is all the setup we need here, but we need to go back to accelerate and we play start stream here. And then for decelerate, if we didn't play end once, and this should be negative, of course, and played end ones. Need to play ending sound. End stream, and say played once to true. And this should be all that we need. One thing though is we need to check our streams to see whether they are set properly. So as you can see, if I double click on an MP3 or WAV, we have this audio stream importer. And for end, we don't want to loop. For loop, we want to loop, and it's enabled already. And for start, we don't want to loop. So this looks correct. Let's play this and let's see how this sounds. Okay. Okay, pretty good. But what we need also is the explosion sound. So let's find that. Let's find explode function here. And we need to say audio stream player stream is equal to explosion sound. And we need to play it. Audio stream player play. Yeah, just play. That's all. And let's see that. Okay. Perfect. So we have the explosion sound for our plane. The other things is we need to the sound for shooting. So here I will add another audio stream player, and I will call this shooting stream player. And what we can do here is click and go to inspector and assign the stream directly. So this is going to be shoot. And whenever we shoot, we just grab the reference to that and we'll just say shooting streaming player play. So let's see how that works. Okay, one issue that I see that we should fix is if we destroy the bridge, it can still collide with missiles. We bring that sound down. Just so you can hear it barely. Okay. So to fix that, let's go to a bridge and when we explode, we also need to disable the missile collision. So set collision mask value, the layer is free, and set this to false. It still collides, so problem is going to be probably here. Right? Okay, let's see. Oh, but now we can't actually collide here. So to fix this, we need to move that code to the bridge. So let's see, this is that and that. So on body entered, but we can also add area entered. If area is missile, we will do explode as well as, let me see, can do that, and then in bridge will explode, as well as setting collision value here to false. Yeah, now it works. Perfect. So the other things is we need to, in our enemy, also play the explosion sound. So let's go here to add audio stream player. It's going to be the same, so we can just apply bomb explosion sound, grab the reference to it, and when we explode, let's just play this. Sorry, that's gonna be audio stream player play. So let's try this, and to test this, let's move our player right down here. Okay, so this works good. The one last thing is that this should also play the sound when destroyed. So basically, let's do the same. Find the inspector. And explode is here. Grab the reference. And let's do audio stream player. Play. Oh, also, I believe we're missing the very same functionality in a bridge. Let's see. Explode. Grab the reference. Audio stream player. Play. Perfect. Okay, so we have sounds set up in our game, and that basically finishes this tutorial. This should set you up to creating your own aircraft, I know, space shooting 2D game. All the basic functionality is here. I encourage you to, of course, grab this tutorial, adjust it to your own needs, make it into a full game, and work on it more to learn more about Godot. But I am leaving you with this. If you have any questions about this tutorial, please post those in the comments. I will try to respond to them to the best of my ability. And right now I'm going to sleep because I'm very tired. So thank you all. If you'd like this, please comment, subscribe, give a like. I really appreciate it. And I will work on more tutorials soon. Take care. Bye.